Hey everyone, how's it going? This is Michael Craney. I'm here today with Harry Pertel and Jacob Mail, and today we're going to be talking about the Green Thumb Smart Nursery, which was our senior design project for ECE 453.
First, let's take a quick look at the finished product. As you can see, we got the lighting system and watering system all automated and ready to go. We got some healthy looking jalapenos and cilantro planted in the soil there with the moisture, pH, and temperature sensors all hooked up and connected to the app. Now let's take a quick look at our functional block diagram. Now, the main board acts as the central hub for all the devices. The peripheral sensors communicate with it through I2C, sending arrays of 8-bit numbers when requested, and the board then translates these packets into recognizable values such as temperature and sends it to the app over BLE, which gives it to the user to display on the screen. Now, the app then uses that same BLE connection to let the board know which lighting and watering modes it's in and the specific variables that it would need to run the schedules with that mode. Certain data the phone can send will set variables in the board that will alert it that it needs to turn on the lights and the motor. The lights are connected to an outlet that has a mechanical relay that we toggle with a GPIO pin in the CPU. And the motor is connected also to a GPIO pin, but we toggle that by changing the compare value in a PWM signal that will speed up or slow down the motor.
When we designed our greenhouse, we thought of it as the hub that would control and automate all of the electronics that go into indoor growing. To do this, we created an outlet board that users could plug their lights into in order to be automated by our software. We also created an adjustable light rack that users could replace for cables or anything that would move the light as the plant grows. For the physical design of our box, we put our power outlets high and away from any water that would splash and possibly damage the outlets. We also mounted our motor right onto the box in order to avoid shaking as it would on the interface board. We created a protective and semi-waterproof case for the interface board, put our water inside the planter to keep it away from the interface board and stop it from spilling anywhere it shouldn't, and then raised the water hose above the dirt level so that no dirt could get in and plug it.
All right, then just to go ahead and talk a little bit about the design decisions we made in regards to hardware. Starting out, we have I2C communication between all of the sensors, so that includes our temperature, moisture, as well as our pH sensor and the main Cypress MCU. They are all sharing an SDA and SCL line through which they communicate. We also decided to put the temperature board on a dedicated PCB. The reason for this is the interface is pretty far away from the plants, and it's also outside of the range of the light, which definitely adds some heat to the environment. So a detached positionable temperature board seemed to make more sense to get a more accurate reading of the temperature near the plants. We also decided to go with DF13 wired connections between the components themselves. The locking in nature of these wires provided us some peace of mind that the connections would stay good, and it also allows us to easily unplug the components when needed, which can provide some security when you're powering the boards and things like that. We also laid out the peripheral connection ports on the same side of the board. There were two reasons for this. One, it lets us easily connect all the components when we need to. And second, if we decided to go forward with some sort of 3D printed casing, it would be a lot easier to create the holes we needed. We also have GPIO toggled N-channel FETs that are connected to the lights. We also set up an extra outlet that could be maybe used for an additional water driver or water motor, and we also had that connected to the motor driver as well. And so this allows us to easily toggle the power to these devices with simple GPIO writes. And then finally, we have the power supply. So we needed 12 volts for the pump, 5 volts for the motor driver, and 3.3 volts for the MCU and some of the sensors. So we chose 12 volt wall wart over 5 volt because 12 volt needed a lot more current for the pump. And so then we bucked the 12 to 5 and 12 to 3.3 with the TI regulator. And we had no need for a battery since it's not a mobile device.
Okay, now I'm going to talk about some design decisions we made for software. The first thing for the app was just an easy to understand GUI with as little elements as possible, with the intended functionality still achieved. And the whole thing is just visually clean, and it's only got what the user needs. Now the connection via BLE to Cypress is just done by click and connect when near the board. It takes it totally out of the user's hands, they don't have to worry about it. And the temperature and moisture readings are taken immediately on startup and sent to the app. And the app receives readings from the board, and in return, the board receives info for starting and adjusting various timers and selecting care options. The board has timer functions that run concurrently for lighting and watering timers, and all run in a function that takes exactly 1 second for each interaction. Each action and timer also prints out to the UART, which was super helpful for understanding how the app was running, especially with a project like this. Not much is happening visually. And now I'm going to go over the lighting options. So lighting has two options. The first one is just an obvious light switch, toggles the lights on, toggles the lights off. The second option is a 24-hour schedule where you pick the start and stop times for each lights and it adheres to those every day. Next, for watering, you have a couple more options. The first thing you have to decide is the watering amount. All the user has to do is type in the number of cups they want, decimals are allowed, and the software converts this into seconds of running the motor. We figured out this conversion rate ourselves through testing, and this is the amount used for all of the following watering modes. Watering manually works a lot like toggling the lights. It just waters the set amount exactly when the button is pressed. The watering schedule also works similarly to the lighting schedule, but instead of picking start and stop times for a 24-hour cycle, it lets you pick how many days should pass between waterings and the time that watering occurs, which is more in line with how people normally care for their plants, or at least how I do. Choosing automation takes the watering issue totally out of the user's hands. When this is selected, when the moisture sensor detects a low reading, which is under 20%, it will water for the set amount. I will then wait for a cool down timer to complete to avoid overwatering and allow the water to soak into the soil enough to get picked up by the sensor before scanning again.
Now to talk a little bit about the problems we faced. In terms of the peripherals, one thing early on, we plugged in the programming header backwards. This resulted in a short in the circuit and we had to replace the Cypress MCU. We also were having issues with the I2C line after a short occurred with the motor pins. And after that, the A to D for the PH was shorting the SCL SDA line. So once we removed that component, that fixed that problem. We also had to rotate the MOSFET for one of the pins because it was misaligned with the CAD model and the source was not where we expected it to be. And then finally, we had to dig through the Adafruit code to find the I2C packets to get responses from the moisture sensor because they weren't directly provided by Adafruit.
A problem we had with the power supply was that one of the pins on the wall wart was floating and needed to be grounded. I fixed this by wiring that pin to ground. Another problem we had was that the linear regulators were tiny and only had pads on the bottom of the component, so I had to mess around quite a bit with the heat gun to get them properly aligned. The last problem we had with the power supply was that on our outlet board, I accidentally mixed up ground and neutral when wiring something that we were going to plug into the wall. When I plugged this in, it made a huge spark and was very shocking.
On the software side of things, one of the big challenges I faced was I had no experience in app design before, and I had to learn all that from scratch, which was a really big learning experience, but something I'm glad I did. And a big hurdle to overcome in that process was getting the phone and the board to communicate with each other over BLE. While the board was communicating fine with the devices over I2C and the app was running correctly, getting them to actually communicate with each other and send the necessary data packets back and forth was a huge issue and something that I spent a lot of time researching and figuring out.
So finally, we'll just run over a couple of things we'd do differently if we were to do it again. So one thing that was pretty big for us was at least using 2 moisture sensors, maybe more. Only using 1 moisture sensor kind of limits you to getting the readings around a single plant, and especially with a planter box as big as we used, having more moisture sensors and averaging them together would just give you a better idea of the actual status of the soil. Another big thing, we would probably integrate the interface board with the power board into one nice package. It kind of goes along with that off-the-shelf automated greenhouse thing we were talking about earlier. Another thing, we'd order more backup parts. Obviously, the A to D converter failing is the reason we weren't able to get the pH sensor functioning correctly, so that's definitely something we do differently. And then also just more functionality in the mobile app. Specifically, we were considering doing things like plant profiling, where common plants would have light cycles and watering associated with them already, and so then users could just easily select whatever plant they're trying to grow in the greenhouse, and all those settings would be configured for them. And now we'll have a little demonstration video.
Now we're opening up the app, and all you have to do is push the button connect device, and we do the rest. You can see connection was successful, so we're going to continue. You can see our temperature, moisture, and pH readings all set up there. Now we can see we can toggle the lights with the flick of a switch, and we can also set a schedule. Now we can also adjust the watering. So you can see we'll set the cups of water to 2.5 cups. And we could hit water now, or we could set to, let's say you want like a weekly schedule, you could set it to water once a week, or you could automate, but we're just gonna water it right now so that you guys can see that running. And that's our presentation. Thanks for listening, and a big thank you again to Plexus for sponsoring this project.